an implementation. They basically benchmarked a competitor and metrics. After 3 weeks, the competitor had reached 79% accuracy. And what we mean by this is they were able to identify correctly 79% of the known duplicates in a standardized data set. Fletcher, on the other hand, left at 3 o'clock in the afternoon on the first day, and we discovered the next day that we had found 97% of the known duplicates. So they naturally picked metrics. We conducted a 2-phase project with them. The first was to clean their database. Essentially, they sent us their 5.5 million records. 2.3 million were duplicates, and those 2.3 represented 1 million unique entities. So they ended up with a database, now a reference database of 4.2 million entities. And then we automated the matching of incoming results. Just to give you an example, before Netrix, they were able to automatically match 65% of those incoming results, and after Netrix, 95+% are matched automatically to the correct entity. So what that means is that they have obviously much greater levels of automation, and their subject matter experts are now able to do their real job rather than searching through databases trying to find the right record. So it's better quality at lower cost. And now you see a diagram of their ingest process, and this pretty much applies to any implementation. There's some code that is written. In this case, of course, with Data Foundations, that code is the one data product. Data comes from sources, is brought into that ingest process. A request is sent to the matching engine. A result set is returned to the application, and the application then decides what to do. If it's above a particular score, then the record is automatically matched or linked. If it's below a particular score, then it's never been seen before and some action takes place. And certainly for very high value problems, records that are between those two scores, the gray zone, as it were, are sent for human review. This is a typical deployment. I'm not going to spend too much time on this. Essentially, there's an application, an existing or a new application, and some underlying database management systems. The Netrix matching engine fits unobtrusively into that environment. Couple of highlights about the engine: that you can have, for instance, multiple instances of the matching engine, each with as many tables as are required. All communication is through standard TCP/IP sockets, but that's hidden from the application by the Netrix client. So that client basically marshals the requests and returns the result set to the requesting application. The data can be partitioned and or replicated to enable scale for very large data volumes or very high transaction rates. And the loader syncer is provided to help with the initial load of the data from those underlying databases and for keeping the matching engine in synchronization as changes, as inserts, updates, and deletes happen in the underlying database. So just to review the capabilities, the point here is that you have very fine-grained control over each matching request. Multiple scoring modes, multiple cutoff modes can be used based on the problem that's being solved. There's a differential weighting scheme so that you can, for instance, give greater weight to matches in the last name field compared to the first name field, and do this by individual fields or combinations of fields or fields within combinations. We can raise or lower the contribution of specific tokens, and also based on the length of tokens. We have tie-breaking schemes so that if you have multiple very high-scoring records, you can automate the picking of the record that most closely matches according to your criteria. You're able to nest match components and operators to deal with very complex matching problems in an automatic way. We support the use of thesauri, basically semantic equivalent sets that can be invoked or not for each matching request. So, for instance, we supply a nicknames thesaurus so that Margaret is the same as Peggy, is the same as Midge, the same as Madge, and so on and so forth. And the thesauri are error tolerant. So you can have errors both in the data and in the request and in the thesaurus, and the records will be linked. The records will be linked despite those errors. In summary, Netrix provides an innovative use of advanced mathematics to solve really tough matching problems. So thank you, everybody in the audience, and back to you, Charlie.
Thanks, Dave. Moving on, the question of domains is broader than just this discussion of the business metadata layer, so let's talk about standard reference data. Reference data is made up of critical, industry-defining code sets, reference entities, and hierarchies. As you know, code sets carry a description such as approval status or age group, and a few set of standard attributes which probably have conditions such as effective date, superseded by, supersedes, etc. But not every insurance organization follows the code set description paradigm, and what we've also often seen are companies utilizing organizational or geographic subdivisions, where in addition to keeping the code description, other attributes are attached. So, as in this example, in addition to the description name, country is further enriched by its ISO Character 2 code, its FIPS code, the primary currency, and so on. Code sets as described here can be part of metadata as mentioned earlier. But I doubt it's overly assumptive to say that insurance companies have embraced the strategic control afforded by hierarchies and the relational support of key data items. These structures can be expressed quite simply, as in an organizational hierarchy, but can evolve based on need to represent numerous business requirements such as charts of accounts with its own specialized characteristics or an ownership hierarchy. Here's one for you hierarchy management mavens. Take a look at this LAH or Life and Health ACORD standard. At first glance, it's a rather scary mesh of carriers, producers, and distributors. Without benefit of a lifeline, no joke intended, can you visualize the hierarchy that might be best deployed to represent this graphic? I don't have the Jeopardy music license, so, well, time's up. In the hierarchy terminology, this is a network recursive structure where a node can be a producer, a carrier, or a distributor, and a node can be linked to multiple parents. ACORD provides 429 P&C code sets. This is an exhaustive and, personally speaking, fascinating list of code sets. By the way, can anyone tell me the application difference between breed and dog type? How about amusement device? Let's not dwell on that for too long. In any case, most of the ACORD code sets are code description, with a few exceptions. 12 exceptions, actually, that employ two levels. The reason being, if we take policy type, for example, we need another descriptive level, as a calamity caused by flood is not the same as calamity caused by fire. Now let's talk about the integration of ACORD as an external standard. ACORD is good because it's inclusive and comprehensive. It facilitates data reuse, which is a data foundation's mantra. And as you may have concluded, it works very well for P&C. Each of the components from ACORD fit very well with the framework we are presenting, as well in terms of business metadata with the interchange formats, business dictionaries and models, master data with the data and component models, reference data with the code sets embedded in the interchange specifications. So let's make the case for ACORD by considering some of the problems or challenges it helps mitigate or even eliminate. Here, for example, is ACORD's solution or standard for the clientele age group. How does that help us